Welcome to Astronomy Daily, your latest source of space and astronomy news, with your host, Anna. Today, we're diving into some fascinating topics ranging from the latest findings about Mars's escaping water to the exciting flyby of Mercury by the Bepicolombo mission. We'll also discuss China's ambitious plans with G-Space's new low Earth orbit satellites, SpaceX's launch of next-gen spy satellites, and how amateur astronomers are aiding the study of Jupiter's weather. Stick around for an engaging episode packed with the latest updates and discoveries from the cosmos. Let's start today with a Mars update. NASA's Hubble Space Telescope and Maven mission are making significant strides in unlocking one of Mars's biggest secrets: what happened to all its water. Mars was once a very wet planet, evidenced by its surface geological features. Over the past 3 billion years, scientists suggest that some of this water went underground, but where did the rest go? The Hubble and Maven missions have combined data to offer answers. There are only 2 places water can go, explains John Clark from Boston University. It can freeze into the ground, or the water molecule can break into atoms, and the atoms can escape from the top of the atmosphere into space. Essentially, Clark's team needs to understand how these atoms escape to gauge how much water Mars once held. Water molecules in the Martian atmosphere are broken apart by sunlight into hydrogen and oxygen atoms. Clark's team focused on hydrogen and its heavier cousin deuterium, which has a neutron in its nucleus. Because deuterium is heavier, it escapes Mars's atmosphere more slowly than regular hydrogen. By measuring the current ratio of deuterium to hydrogen, scientists can work backwards to estimate the amount of water Mars used to have. What makes this study groundbreaking is the combination of data collected over different Martian years. Maven, not sensitive enough to detect deuterium throughout the Martian year, relied on Hubble's data to fill in the gaps, offering a complete picture. This holistic approach over years allowed a more dynamic understanding of Mars's atmosphere, showing that it is much more turbulent and changes more quickly than previously thought. One significant discovery is that hydrogen and deuterium escape rates spike dramatically when Mars is closest to the sun. Traditional models had shown these atoms slowly diffusing upward, but the new data indicate a more rapid and energy-intensive process. Collisions with solar wind protons and sunlight-driven chemical reactions help give these atoms the extra kick needed to escape Mars's gravity. Beyond understanding Mars, the study offers insights into the evolution of planets around other stars, especially Earth-like planets in habitable zones where liquid water might exist. Mars, Earth, and Venus all occupy or very near our solar system's habitable zone, but have vastly different environments today. By studying Mars, we gain a better understanding of these distinctions and their implications for distant worlds. The Hubble Space Telescope and Maven missions have been crucial in this research. Hubble, a joint project between NASA and ESA, has been studying the universe for over 3 decades. Meanwhile, Maven, managed by NASA's Goddard Space Flight Center, is preparing to celebrate its 10th year at Mars. Both of these missions underscore the importance of international cooperation and long-term investments in space exploration. Thanks to the efforts of these powerful telescopes and the dedicated scientists interpreting their data, we are one step closer to understanding not only the history of Mars, but settings more applicable universally. Now let's turn our attention to some groundbreaking news from China. Chinese automaker Geely's G-Space has announced an impressive milestone with the launch of 10 low Earth orbit satellites. This launch is part of their ambitious plan to form a global communications mega-constellation. Essentially, it's China's answer to SpaceX's Starlink, which has already revolutionized the satellite communications industry. These 10 new satellites were launched from the Taiyuan Satellite Launch Center in Shanxi Province, significantly extending the capabilities of G-Space's constellation. With this batch, the constellation now boasts 30 satellites, covering 90% of the globe with 24-hour communication services. That's a massive achievement for G-Space, and marks the first time a Chinese commercial aerospace company has offered low Earth orbit satellite communication on a global scale. G-Space was established by Geely Technology Group in 2018. Their mission? To research, launch, and operate low orbit satellites that can provide global broadband services, and they're well on their way. Their initial plan includes placing 72 satellites in orbit by the end of 2025, aiming to serve over 200 million users worldwide. But that's just the beginning. The company plans to expand its constellation to nearly 6,000 satellites. This robust network will be designed to offer global broadband services, positioning G-Space as a strong competitor to Starlink. LEO satellites typically orbit at altitudes of 300 to 2,000 kilometers above the Earth's surface. One of their main advantages is that they're cheaper and provide more efficient transmission compared to those in higher orbits. G-Space's deployment strategy leverages these benefits, making it a cost-effective and scalable solution for global communications. G-Space's endeavor is part of a broader wave of Chinese companies entering the satellite communications space. Another notable player is Shanghai Spacecom Satellite Technology, which has also launched LEO satellites under its Thousand Sails constellation, or the G60 Starlink plan. They have equally ambitious plans, aiming to deploy 15,000 satellites by 2030. It's clear that China is heavily investing in satellite technology to ensure they're not left behind in this new space race. G-Space's latest launch is a significant step forward, not just for Geely and G-Space, but for the overall landscape of global satellite communications. This competitive spirit and rapid technological advancement could lead to more affordable and accessible communication services worldwide. Speaking of that other satellite communications company, SpaceX is showing no signs of slowing down. On September 5th, one of SpaceX's Falcon 9 rockets launched from California's Vandenberg Space Force Base. This wasn't just any mission. This launch sent a new batch of next-gen spy satellites into orbit for the U.S. National Reconnaissance Office, or NRO. It was their 86th orbital mission of the year, underscoring just how prolific SpaceX has become in the realm of space launches. What's intriguing about this particular operation, known as NRO 113, is that it's part of the NRO's new strategy called proliferated architecture. This concept involves deploying numerous smaller satellites to create a network designed to be more capable and resilient than traditional single satellite systems. In simple terms, having more satellites in orbit can ensure the network remains operational and less vulnerable to threats. SpaceX's efforts didn't just end with launching the satellites. The Falcon 9 booster used in this mission also executed a flawless landing. About 8.5 minutes after liftoff, the booster settled back down onto the deck of the SpaceX drone ship, Of Course I Still Love You, floating in the Pacific Ocean. This marks the 20th time this particular booster has been launched and landed, highlighting the reusability goals SpaceX founder Elon Musk has championed. Interestingly, this wasn't the only mission SpaceX managed that day. Earlier on September 5th, another Falcon 9 rocket launched from Florida's Space Coast, delivering 21 Starlink internet satellites into orbit. This shows how SpaceX has become adept at handling multiple missions almost simultaneously. While the exact details of these spy satellites remain classified, as is typical with NRO missions, it's clear that they play a critical role in national security. The NRO has described prior launches in this series as essential to their proliferated architecture strategy, and this third launch in the series continues to build on that foundation. It's a testament to the growing relationship and trust between SpaceX and government agencies for crucial and classified missions. Now let's turn our gaze to Jupiter. With its iconic Great Red Spot and swirling, turbulent atmosphere, has long fascinated astronomers and space enthusiasts alike. While professional observatories and high-cost missions like the Very Large Telescope in Chile and NASA's Juno orbiter have offered invaluable insights into Jupiter's meteorology, they can't monitor the gas giant continuously. This is where amateur astronomers, armed with relatively affordable telescopes, are stepping up to the plate. A recent study published in Earth and Space Science highlights how amateur astronomers can significantly aid in this endeavor. Using equipment costing as little as $4,000, these aficionados are making sizable contributions to our understanding of Jupiter's atmospheric phenomena, especially its cloud formations and ammonia distribution. You see, Jupiter's topmost clouds aren't water-based like Earth's, but are primarily composed of ammonia ice. By analyzing the absorption of specific wavelengths of light, 647 nanometers absorbed by ammonia and 619 nanometers absorbed by methane, amateur astronomers can determine the abundance of ammonia in different regions of Jupiter's atmosphere. Methane levels remain relatively constant and well-studied, allowing for this comparative technique. Higher absorption at 647 nanometers compared to 619 indicates increased ammonia content, providing critical clues about Jupiter's intricate weather patterns. This simple yet effective method has allowed researchers to observe changes in ammonia distribution over various timescales from weeks to years. However, more comprehensive data is needed to better understand what these fluctuations signify and how they influence Jupiter's overall weather system. Amateur astronomers are perfectly positioned to fill this gap, and the researchers hope these celestial hobbyists will rally around the cause, making regular observations. With a larger global network of observers, we can capture a much more detailed and continuous picture of Jupiter's atmospheric conditions. This would enable weekly or even daily monitoring, a feat that's unmanageable with sporadic professional observations alone. By joining forces, citizen scientists and professional astronomers can unlock new levels of understanding, helping us unravel the complexities of not just Jupiter, but planetary weather systems in general. Whether you're an experienced stargazer or a curious newcomer, your contributions could make a meaningful difference in space research. So, if you've ever pointed a telescope at Jupiter and marveled at its grandeur, consider becoming part of this significant scientific effort. Whether you capture an image of a swirling storm or a fleeting atmospheric anomaly, your work might just change our understanding of the largest planet in our solar system. Now on to Mercury. The Bepicolombo mission completed its fourth and closest flyby yet of Mercury, a fascinating event that has offered us brand new, unprecedented views of the planet's South Pole region. This close encounter took place on September 4th, marking a significant milestone in the mission's journey toward a comprehensive study of Mercury. A joint effort by the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA, Bepicolombo whizzed just 165 kilometers, about 103 miles from the surface of Mercury. Not only did this flyby produce stunning photos, but it also played a crucial role in adjusting the spacecraft's trajectory to match Mercury's more inclined orbit relative to Earth. The primary objective of these flybys is to slow down the spacecraft, effectively using Mercury's gravity as a brake to ease it deeper into the sun's gravitational pull. Unlike missions that slingshot past planets to gain speed, Bepicolombo needs to decelerate to ensure it gets captured by Mercury's minuscule gravity. Launched in 2018 and named after Italian scientist Giuseppe Bepicolombo, this mission is unique. It consists of two orbiters, ESA's Mercury Planetary Orbiter and JAXA's Mercury Magnetospheric Orbiter, stacked together aboard the Mercury Transfer Module, MTM. These orbiters will separate once they're inserted into Mercury's orbit in late 2026 to commence their primary science mission. The recent flyby was a pivotal event for the mission, providing a unique opportunity for the scientists involved. Johannes Benkoff, ESA's Bepicolombo project scientist, emphasized how crucial these flybys are for both navigating the spacecraft and preparing for its scientific mission. He noted, "We get to fly our world-class science laboratory through diverse and unexplored parts of Mercury's environment that we don't have access to once in orbit. Even though the main science camera aboard ESA's orbiter remains shielded until final orbit insertion, 10 of the spacecraft's 16 instruments were active during the flyby. These instruments collected valuable data on Mercury's particles, plasma, and magnetic fields. Additionally, the Japanese orbiter's monitoring cameras captured striking black and white images of the planet's terrain, including unusual double-peak ring crater basins. Interestingly, the close encounter was made possible due to an issue discovered earlier this year. The spacecraft's electric propulsion system wasn't operating at full power due to unanticipated current levels between the solar arrays and the electrical distribution system. This glitch led the mission controllers to plan a closer flyby, thereby also extending the mission timeline to late 2026. Once Bepicolombo enters Mercury's orbit, it aims to transform our understanding of this enigmatic planet. The mission will investigate everything from Mercury's internal structure and surface geology to its magnetic field and exosphere, promising to enrich our knowledge of the smallest and innermost planet in our solar system. Bepicolombo's journey has been extensive, involving one flyby of Earth in 2020, two of Venus in 2020 and 2021, and now 4 of Mercury, with 2 more scheduled before final orbital insertion. After nearly 8 years in space, the mission is poised to deliver groundbreaking science starting in November 2026. Thank you for tuning in to Astronomy Daily with Anna. For more space updates, visit our website at astronomydaily.io to sign up for our free daily newsletter. Catch up on all the latest space and astronomy news with our constantly updating newsfeed, and listen to all our back episodes. You can also find us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok. Until next time, keep looking up.